under content, under Boolean logic, 7408, okay, this is the 7400 chip schematics, and it's got a diagram that will tell you, first off, that the AND gate is chip 7408, and it gives you the pinouts for the chip underneath here. So this is a diagram that shows me the pinouts for the logic functions on the integrated circuit. So pins 1 and 2 are input pins for an AND gate, and pin 3 is an output pin for an AND gate. So you probably need this to refer to. Almost all of the 2 input gates are the same, with the exception of the 74LSO2. If you look at this chip, pin 1 is the output of a NOR gate, not an input. This is the only one that's exceptional, and when I posed the question, I gave you the puzzle that required a NOR gate, I reminded you that the pinouts are different. So this is how you can find out which chip you need and what the pinouts for the chip are. If you look at the 7432, the pinouts are identical to the 7408. And since I'm only using 2 gates, I only need to know that pins 1 and 2 are my input and pin 3 is my output. This is where that information comes from this sheet of paper from the chip schematics. So now, I'm going to go to TinkerCAD, and I've got my basic components here. I'm going to build the basic framework of this experiment, which is simply a breadboard, an Arduino to provide power, and an LED and a resistor to give me output indication. So I'm going to put my resistor here, I'm going to put an LED here, and I'm going to zoom in on this so you guys can see a little better. Everybody see that okay? Now there's different sizes of breadboards. If I want one that's longer, this one doesn't provide me enough room. I can get a bigger one. To put 2 chips on, they'll certainly fit on this small board. All right, and then I'm going to take my Arduino and I'm going to hook up power and ground to the buses. And a bus is just a conductive pathway. These, the ones that are configured horizontally at the top and bottom of the Arduino. So I'm going to take +5 volts and I'm going to wire it to the plus bus. That's the positive connector. And I'm going to use a red wire for that. And I'm going to take the ground and I'm going to hook it up to the negative bus, and I'm going to use a black wire for that. And then down at this end, I'm going to connect the red to the red using a red wire. And I'm going to connect the black to the black using a black wire. Now what I've done is I've made it so that power is available on both the top and bottom of the breadboard. So if I want to access it, it's easy to connect to. I don't have to have wires running over top of my chips. Not that it matters when the wire is virtual and it's just a line on the screen, but when it's an actual wire, you don't want things to go over other components because then it gets hard to swap a component out if you have a failure or another need during your experiment. Okay, so now I'm ready to get my chips out. They're under all components, and they're down at the end under logic. So here they are. So I'm going to need the quad AND gate, the 7408, and I'm going to need an OR gate, the 7432. I put them both in the middle of the breadboard. They straddle the gutter. I'm going to make lots of room. So I got lots of room so I can understand what's going on. Okay, my light here, which is what is going to indicate off and on, this resistor value needs to be 220 ohms. It'll actually work if you leave it at a kilo ohm. The light will still come on. I just change the value just because it's a matter of good practice. And if I actually used a 1 kilo ohm resistor like the one that was here, the light wouldn't come on or it'd be very dim if it did. And then I need to connect the cathode of the LED to ground. So I'm going to do that right here. Somebody's got questions?
Yes, why'd you do it to that one? You could have done the other side to make it look nicer.
Why did I do it what?
You could have connected to the other side, the other ground one.
The other ground? I could have, but then it would have been either running across. I just wanted to make it so you could see it easily. If you can't see it, it hides behind the LED if you do it that way. Sorry, Quinn. I've disappointed you. I brought shame to my family. Okay, so this is the output circuit, and then the only thing I'm going to have to do is wire whatever pin ends up being the output from the circuit to the input right here. So that's how the LED is going to work. Power comes through the resistor, through the anode of the LED, which is the longer lead, the one that comes off at an angle, lights up the LED, and then proceeds to ground through the cathode or the other. This is on the diagram that's given to you. All right, so looking at my diagram here, I've got two inputs, A and B, and they both go into the 08 chip. So that's going to be these pins, A and B. Those are my input pins. I'm not going to worry about them for now because the inputs are the last thing I hook up. That's when I test the chip. The output pin from the AND gate, where does it go?
Into the OR gate.
Into the OR gate. So my input pins on the OR gate are pins 1 and 2 on this chip. So I can just run a wire from pin 3 on the 08 to my output here. But I've forgotten one step. What have I forgotten to do? These won't work. Why won't they work? Yes?
You have power and ground into your chip.
I have to provide power and ground to the chip. So power always comes at pin 14, and it's always red. So I do that for both the chips. And ground always goes at pin 7, and it's always black. Okay, so now my chips are powered and grounded, so they'll work. Now what I want to do is I want to run a wire of a different color from the output pin of the AND gate to the first input pin of the OR gate. Okay, where does my other input for the OR gate come? It comes from input B. Which pin is input B? Which do we decide? Pin 2 on the AND gate. So that's now 2 inputs to the OR gate. Where does my OR gate's output go?
Resistor.
Yeah, to the resistor because it's the output pin. It's the result of this. And it has to go to the LED to let me know if the circuit is positive or negative. You know, a 1 or 0. When's it a 1?
When it's on.
When the light's on. Okay, so I have 2 inputs. They are here, pins A and B. To set it as a 0, what do I do? Yes, John Owen. Put it to the ground. So on my truth table here, my first set of possibilities is 0, 0, right? So set pins A and B to ground. So I'm setting them to the negative here. So there's pin A and there's pin B. And I'm going to make these wires a 3rd color, 4th color. Let's make them blue so that we know that they are the input ones. Okay. So this circuit looks like it should work. Pins A and B are set to 0, which is the first trial in my truth table. To find out what the result is, I start, and my result is indicated here at the light. What's the condition of that light?
0.
It's off.
It's off, so it's a 0. So I can place a 0 in the truth table. Okay, stop my simulation. The next choice is 0 and 1. So I wire it to the positive. So input A stays wired to the ground, which is 0. Input B gets wired to the 1, which is positive. Start the simulation. What's the condition of the output? Yes, it's a 1 because the light's on. So I record that in my truth table. Okay, stop the simulation. Next possibility, input A is a 1, so I wire it to what? The positive, right? Input B is what's input B? 0, so I wire it to the ground. Start my simulation. What's my output? 0. The light's not on. And my last possibility would be 1 and 1. So I'm going to hook both input pins up to positive and start the simulation. And what's my output? 1, because the lamp is on. Okay, let's test this. Let's test this using a tool that we know. So let's use the, where's my logic gate simulator? There it is. So let's use the logic gate simulator to build this. Why would I do this? Just to test and to show you that they're the same thing. Just using the chips is a simulation of actually physically wiring it and getting an electrical result, as opposed to, just the result of a program. So I'm going to need, for this, 2 inputs. So I'm going to add a second one. I need 2 gates. I need an AND. And I need an OR. And I need a single output. Okay. So there's my 2 inputs. They both go into the AND gate. Input B goes down and becomes the second input in my OR gate, so I'll wire that there. And the result of the AND gate becomes the first input into the OR gate, and there's my output. Okay, so now I built the circuit, but in logic, not with chips. It should behave in exactly the same way. If it does not, something's wrong with either my logic circuit or with my actual circuit. Which one do you think is more likely to cause you problems? Your actual circuit is more likely to cause you problems. It's more complex. And then when you actually make it, when you make it in physical reality, it's even more complex. So this should be right. Okay, so 0 and 0 gives me an output of 0. Well, you guys can't see my inputs. 0 and 1 gives me an output of 1. 1 and 0 gives me an output of 0. And then 1 and 1 gives me an output of 1. So this provides the same truth table that the actual TinkerCAD circuit using the chips did, correct? So that leads me to believe that what I've done is correct. I mean, I could have made the same error in both the logic puzzle and in the TinkerCAD puzzle, but that's pretty unlikely. So I'm pretty sure that this is correct. Any questions? Does this help? Yeah, some people, I found you guys were asking all the same questions all the time yesterday. So yeah, I'm going to turn you loose and you can work on your logic puzzle.